Okay, in this lesson, we're going to relate the whole concept of proportions to similar figures. Similar figures in geometry just means that you have the same shape, but they're different sizes. What we know about this is the ratio of the dimensions are proportionally equal. So we're going to use that to help us solve for the length of the missing side. Okay, so for this first example, we have a rectangle that has a length of 12.5 centimeters and a width of 7.5. Now for some people, it's really helpful to draw a picture here. So we had a length of 12.5, so our longer edge is going to be 12.5 and the shorter edge is going to be 7.5. Okay, a similar figure, now this whole term, similar figure, similar rectangle, just means it's in proportion, has a width of 3 centimeters. So I could draw a smaller figure here, and we know that its width is 3. So that's what we're looking at here. Okay, so really, I wouldn't really have to draw a picture. I just know that my length and width ratio are going to be equal to each other between these two figures. So you could kind of set up an array like this. This would be our large rectangle, and this would be our small rectangle. Looking at this is actually a scale factor that we're setting up here, but I don't think you need to worry about the name of it. The length of that large is 12.5, and the width of that large rectangle is 7.5. So this ratio should be equal to the ratio of the dimensions in the small figure. In the small figure, we know that that width was 3, so we know that it needs to go down here. So you're going to cross multiply and divide, and I don't want to do all that arrows that I was doing earlier, simply because I know it starts to get a little cluttered. So I'm going to go 12.5 times 3 divide by 7.5. That arrives at a length of 5 for that small rectangle. Okay. The next one I think I could let all of you do on your own. You can draw your own picture. On this next one we have a little bit of it's the same type of concept going on here. A sign pole casts a 6-foot shadow. At the same time of day, a 4-foot child casts a 3-foot shadow. What is the height of the pole? Now, if you hadn't seen this picture here, you wouldn't realize that this had anything to do with geometry. Because what happens when you have the height and a shadow, they're going to be at right angles to each other. So this is going to create a right triangle. Same thing with this height of the child and its shadow. That child's shadow will also be at right angles to each other. So we can set up a proportion here. I could set this up that basically I'm comparing the height to the shadow. I need to probably use the space that's provided to me. The height of the larger figure, I don't know what it is, but I know its shadow is 6. Now the child, his height is 3, and his shadow is 3. So I could go ahead and cross multiply 6 times 24. I'm sorry, 6 times 4 is 24. And then I'm going to divide by 3. So I should get an outcome of 8 here. So our answer is 8, and I'll circle that. Okay, the next one that I want to do for you is actually an isosceles triangle. Just means that 2 sides are equal. So there you're just basically drawing 2 triangles with 2 sides equal to each other. This one is probably the last 2 here I definitely want to take a look at. We have a trapezoid. Trapezoid is a 4-sided figure where you have 2 edges that are parallel. The other 2, there's not a parallel relationship or an equality relationship with either of those. So we just have one pair of sides that are parallel to each other. So we have 2 trapezoids here, but it looks like one is flipped. So what I want you to keep in mind is that you're going to have to think about there's a relationship between this vertical measure and possibly, this vertical measure, this horizontal measure. That relationship should be equal to this vertical measure and this horizontal. So just kind of making sure, rather than labeling length and width, right or left, I'm going to be creating a ratio between my horizontal edges and my vertical edges. So in this case, my vertical is actually 6. So I'm going to put 6 down here. My horizontal is 18. And on this larger figure, my vertical is 12, so that's going to go down here. And I could cross multiply and divide. That, if I needed to identify the expression used, this is what I'd be writing down, because that's exactly what I type in the calculator. So 12 times 18 divided by 6 is going to give us 36. Now down here, I want you to recognize that, actually, you've got a triangle with a smaller triangle set inside it. Okay, a diagram shows a ratio or a side view of a ramp. The larger triangle is partially made up of the smaller, similar triangle. Notice they use that word similar, meaning same shape, different sizes. Based on this information, what is the height of the brace in feet? This is the brace inside that ramp there. We want to figure out that height. So we need to recognize that we have a height of 6 here, our large figure. We have to write down what my word ratio here, if I'm going to really be helpful. So I'm going to look at the large one. My horizontal on the large one I know is 14. The vertical is 6. When I'm looking at the smaller triangle, my horizontal, that's what I'm trying to figure out. I'm sorry, my vertical is what I'm trying to figure out. But I have to kind of do a little bit of thinking. This measure right here is going to be this total of 14 minus this 7 here. I'm taking that away.